Hey guys, and welcome back. So this is the preview of the sim that we made together, and it's looking pretty good. There's a lot of stuff that I like, especially the beginning here. You can see how the particles are separating and falling, so that's all well and good. The main thing that I'm not happy with is this watery like behavior. Okay, and this is something that we would definitely want and like if we were to do let's say a boat trail or any other, pretty much anything that is not a big splash, where we don't have a lot of things floating in the air, and we don't need these repellents or anything, and that's what they're called. Now the masterclass goes into in depth into all this, and please make sure to fully watch that before dive into this section. So what we need for the splash to work properly, we don't need any of these features. We don't need the repellents, we don't need adhesion, we don't need any of it. So I'm gonna turn this off, and let's go back, and I'm gonna turn this off as well. And then what this is basically, remember when I converted the SDF into a surface, inside the volume, inside the surface is negative. So 0 to -1 is inside, 0, 0 is the surface, and then anything above that is beyond the surface. So what this maps to is basically anything underneath below 0 is considered as bubble. Anything between 0, maybe 0.5, maybe something like this, is considered as foam. It's close to the emission geometry, close to the isosurface. Okay, anything beyond that range is considered as mist. So it's not a foam, it's not bubble, it's beyond that. So this is what the range looks like. This is how you should think of it, is where the particle is in that volume, in that emission. And so for a splash, we only care about the positive area, the parts. We only care about the mist, and we're going to use a range of 0.1 and 1.6, and obviously you can explore this more. Now the constraint stiffness is how tight and how much connectivity, or how much it holds the points together. See this group, for example, here it started but quickly separated, and by the end everything is separated. So we can increase the stiffness to hold them together. Okay, we're going to set that to 5 for now instead of 1. And let's go back to, if we open advanced, we see we have more options, and I'm going to try and explain this. So what's happening inside this whitewater solver? Let's create a pop application node. Let's create a pop solver, pop object, and I'm going to create a gravity node that just needs some points. So if we hit play, we get particles falling. Okay, if we use a pop fluid node, you'll see that it has, if we go here, it has the same options, and it has the same, it has constraint stiffness. It has very similar options to what this node has, and it's actually the same node but used inside the whitewater solver. So to fully understand how that section works, the best thing to do is to create a setup like this and then play with the options. Now a very important aspect is the points. This neighbor count can drastically change the syn time. So if we set it to 100, each point is going to consider 200 points while it's doing its calculation. So if it needs to push itself, or if it needs to move closer to those 200 points, that's how much points it needs to consider. The lower the points, the faster, but the less constraint, the less cohesion you're gonna get between the points. So I'm gonna keep this to 40, and let's leave that as it is, and let's lower this. Let's try 1 first. You see now particle separation of 1, it's pushing the points much further. If we set this to 0.01, they're gonna be fine to stay close together. And again, the neighbor also affects this. We don't have a lot of points right now. Let's increase this to 50,000. Okay, so let's take a look. Let's hit play. I'm gonna increase this to 0.05. Okay, and I'm gonna go under neighbors. I'm gonna change this to 200, and let's hit play. You can see already it's getting slower, and we don't have a lot of points right now. So this value is very, very important to keep in mind. Okay, we don't want to go too high, but it's also very important to test. We did some tests as well for that. And then this is how much it's going to push the points, how much connectivity we're going to get between the points. So see, now it's connecting them together, and that's making it look more fluid-like. Let's lower this. And let's increase the stiffness to 20. And this is how much it loops over and tries to connect the points together. And then we have a tensile radius, and this is how big. That's too big. And Houdini crashed. Okay, I'm gonna pause and I will reopen the scene quickly. Okay, so we're back. I'm gonna turn off use OpenCL for now. I know it's been causing some issues under Linux and with my graphic card, so I'm gonna turn it off for now. And again, if you wanted to fully understand all these settings and how they affect the visual here, you can just create a pop fluid and explore with the options as much as you want. And so that's what the whitewater solver is using to connect the points together. Okay, and if we increase the stiffness, if we connect the points together, it's going to keep this binding feature. It's gonna stay there for longer. And we are looking, if you guys remember from the reference, I don't have it at the moment, but if you remember from the reference, the points after they go up and drift, they start to separate. So if we're going to increase the stiffness to hold them back together in the beginning to get more interest in beginning of the splash, we need to do something about that towards the end. And so we need to try different techniques on how we can break this up and add the wind and dissipation to the white water. But for now, I'm gonna leave these options as they are. I'm gonna set this to 40 and this to 80. And I'm not gonna change any of these options. And we want to do a few things here. So in this sim, we don't have any bubbles, okay? And if we set this to 100, it's gonna give it really high chance for the bubble to die. So we're gonna have a higher chance of getting spray only, okay? And I also don't, let me check one thing. We also don't want to get too much foam. So I'm gonna set this to 25, which will give it a basically 25%. I'm not sure if it's 25%, but it's gonna give it a decent amount of chance to die. And then this, it's not gonna die basically. And the other thing that we want is the add state. What this does, it's gonna add an integer that flags the points, whether they are bubble, foam, or spray. So we want that information. And last but not least, I'm gonna introduce some noise to the incoming velocity. And also I'm going to change this offset to 0.05, and this is going to add a slight offset from the emission surface, and it's going to help blend in. Maybe it helps better when we have a complex scene or where we render where we are planning to render the actual mesh, but in this case we're gonna introduce a small offset. And then for the lifespan, I'm gonna lower this to 4 instead of 5 seconds. Okay, let's set this to maybe 0.1. And I'm gonna leave everything to the default. And one last option I need to tweak is the depth range. What this does is it tells the system where the foam is. Okay, what's the level, what's the surface level or the isosurface level, and we're gonna set this to 1. Okay, and that's it. Let's take a look here. And I'm gonna do a preview, and we'll continue tweaking in the next video after we see this. Thank you guys for watching, and see you in a bit. Bye bye.